The majority of homeowners unknowingly has a heat pump installed that is larger than necessary for their home. A heat pump that's too big increases both upfront cost and operating expenses. Oversizing a heat pump can also reduce comfort. In this video, we'll dive into why an oversized heat pump most likely impacts your home's energy efficiency without you even realizing it. I'm Kata, welcome to Net Zero Tech. I explained how heat pumps work in general in multiple videos linked below, so I'll spare you the details in this one. In a nutshell, heat pumps heat or cool your home by transferring heat between the indoor and outdoor environment. Heat pumps transfer existing heat rather than turning a fuel into heat. This way, they can get more energy into or out of the home than is necessary to run the heat pump, enabling efficiencies up to 500, 600, in some cases 700% on a good day. This can save you a lot of money on your electricity bill. It really adds up over time. Plus other advantages, such as a higher level of comfort and clean air. To maximize efficiency, sizing your heat pump is important. If you already have a heat pump installed and think it might be oversized, don't worry, you're typically still way better off compared to oil or gas. The misconception is often that bigger is better, but when it comes to heat pumps, that's not the case. The efficiency of a heat pump is at its peak when it's running consistently at its intended capacity. Oversized heat pumps often experience short cycling, meaning they turn on and off frequently. This constant cycling not only reduces the overall efficiency of the system, but also puts unnecessary strain on the components. Most heat pumps have variable speed motors. That is variable capacity to be precise, meaning they adjust how much heating and cooling they provide based on the temperature outside. Rather than kicking on and off constantly like fixed capacity heat pumps, variable speed heat pumps adjust their speed to the temperature difference. Variable capacity heat pumps are designed to provide optimal efficiency at varying capacities. However, oversizing variable capacity heat pumps is a problem as well. Variable capacity systems are designed to provide precise control over conditions, but oversizing can hinder this capability. Oversized systems may operate less efficiently as they spend more time at lower capacities where the efficiency is lower. And even variable capacity heat pumps can turn on and off more frequently if their lowest speed might still overheat your home. And of course, any change in efficiency also results in a correlating change on your long-term operating cost savings and carbon footprint. Oversized heat pumps can also lead to temperature imbalances in your home. They might heat or cool the space too quickly, leaving some areas too hot or some areas too cold. This inconsistent temperature control not only affects your comfort, but also prompts the system to work harder than necessary to maintain a steady temperature. In humid areas, this can even be more of a problem because heat pumps can act as dehumidifiers. A properly sized system will constantly pull moisture from the air in areas of high humidity, leaving you comfortable and your home mold-free. An oversized system will spend most of its time off, allowing moisture to build up. Even if you live in a dry climate, an oversized system will result in a less comfortable home. The more time a heat pump runs, the more time it has to distribute warm or cold air through your home. If it's constantly kicking on and off, you'll end up with hot and cold spots instead of a steady temperature throughout the home. Oversized heat pumps also come with financial costs. Besides the high upfront cost, an oversized unit will need to be replaced sooner than a properly sized unit. The higher kicking on and off frequency of running below the optimal capacity can lead to more rapid deterioration of the compressor and other parts, so more wear and tear. This, in turn, may result in more frequent repair and a shorter overall lifespan for your heat pump. Heat pumps are usually sized for a certain heating or cooling load at a certain extreme temperature. For instance, minus 15 degrees Fahrenheit, so about minus 26 degrees centigrade, or 105 degrees Fahrenheit, so 40 degrees Celsius, for example. But the climate looks like a bell curve, with only very few hours of those extreme temperatures. So in order to meet the load of those extreme temperatures, the units are vastly oversized the rest of the year. You may have noticed that I love quantifying problems. I think it's the best way to get as close to a rational, unbiased understanding as possible. However, intensely researching for this video, it was challenging to find numbers that are both reliable and up to date. BrightSense estimated the amount of oversized heat pumps at about 98%. Other resources estimate it at 70%, but that doesn't say anything about the metric of efficiency loss of those oversized systems. In other words, it's the frequency, not the intensity, right? If you have any thoughts or resources on energy loss due to oversizing heat pumps, please share them in the comments below. If you Google heat pump calculator, you'll probably find a rule of thumb, something like this. You need 30 BTUs of heat for every square foot of living space you want to heat or cool, and then multiplying that by a factor for your climate zone. They can be tempting, however, these rules of thumb are almost always wildly inaccurate. Of course, there are ways to mitigate oversizing. The key to maximizing your long-term savings is to choose the right-sized heat pump for your home. This involves a careful assessment of your home's size, insulation, and other factors. Consulting with a professional HVAC technician can help ensure that you get a system that meets your specific needs without being oversized. With an air-to-water heat pump, also called hydronic heat pump, a buffer tank is used, which is sized so the heat pump runs 15 to 30 minutes to get back to its set point. If it's too small, the heat pump would short cycle, which is bad for efficiency and bad for wear and tear. Once the tank is satisfied, the heat pump shuts off. Then the heat or cool in the tank gets distributed around the house. When it's mild, this load lasts longer than at extreme temperatures. But once depleted, the heat pump will always run again for 15 to 30 minutes. Hydronic heat pumps can therefore be fixed speed or two-speed. Variable speed like EVI is making its way into hydronic heat pumps now, in part because fixed speed or two-speed compressors are going away and EVI compressors are becoming less expensive. Also because EVI is sexy, but the efficiency gain is limited compared to forced air. With forced air heat pumps, there's no buffer tank, of course, because it makes no sense to store air with its limited thermal mass. That's why variable speed fans and compressors made their way into forced air heat pump systems much earlier. Also because the market, competition, innovation pressure, etc. are much greater. You can vary the fan speed or the compressor speed or both. That said, multi-speed or variable heat pumps are more efficient because at low output, the heat exchangers are vastly oversized, meaning we are transferring a small amount of energy over a very large heat exchanger surface. As output increases, the ratio decreases, and it becomes harder to squeeze a larger amount of thermal energy across that same heat exchanger surface, requiring larger delta T, so the heat pump has to work harder to generate higher temperatures. But even if it's oversized, in almost all cases, investing in a heat pump optimizes energy efficiency. This means lower monthly bills, reduced environmental impact, and a longer lifespan of your HVAC system. A win-win situation for your comfort and your wallet. But oversizing shouldn't hold you back from installing a heat pump. And with a mentioned hydronic system, you can mitigate the risk of oversizing. If you don't have the expertise and/or time to run the tests and calculations, I highly recommend hiring a really good experienced contractor or a building performance contractor. They should get you a blower door test and a manual J load calculation. In conclusion, By right-sizing your heat pump, you can maximize your long-term savings by reducing both operating and capital costs, while living in a more comfortable home and contributing to a more sustainable future. Don't let oversizing hold you back from switching to a heat pump, as the size optimization is just the icing on the cake to the long-term savings of today's high-efficiency heat pump systems. Thank you very much for watching. I really appreciate it. If you found this helpful, you might want to check out Net Zero Tech on Patreon. If you want to learn more about what you need to know before getting an air-to-water heat pump, this is for you. If you want to learn more about hybrid heat pumps, this might be for you. Have a wonderful time and see you in the next one.